So let's go ahead and look at the first problem here. The vertex of the parabola is the minimum point of the parabola. Not always, because if I draw a parabola this way, this would give me the maximum value. If I have a parabola this way, this would be the minimum value. So this is a false statement, as the vertex could give me the maximum or the minimum value. Graph the quadratic function x minus 4 squared minus 1. So the certain steps involved in graphing a quadratic function. First, I would look at the leading coefficient. In this case, I have x minus 4 squared. So the leading coefficient would be 1, and it is positive. Second, if I have a quadratic function, f of x is equal to x minus h squared plus k, then the vertex would be h, comma k. So comparing the one we have here, x minus 4 squared minus 1, the vertex would be 4 comma negative 1. In step 3, would define the x-intercepts. How would I find the x-intercepts? I replace f of x with 0. So I have 0 is equal to x minus 4 squared minus 1. 1 is equal to x minus 4 squared. Finding the square root on both sides, I have plus or minus 1 is equal to x minus 4. X minus 4 is positive 1, and x minus 4 is negative 1. So I have x is equal to 5, and x is equal to 3. The next step is to find the y-intercept. So step 3 is to find the y-intercept. I plug x as 0. So I have 0 minus 4 squared minus 1, which is 15. So putting all these points together, I have, if I say this is 5, this is 4, this is say this is 3, and this is negative 1. So this is my vertex, these are my x-intercepts, and I don't think I'll be having the exact. So this is my y-intercept, which is 15. So this would be my graph. It's a curve here, not alright. So problem 2b. Graph the quadratic function f of x is equal to x squared plus 3x minus 10. Use the graph to identify the function's range. And again, starting with a is 1. That means it's positive. The parabola opens upward. And the coordinates of the vertex, if I have a function f of x is equal to ax squared plus bx plus c, then the vertex, the coordinates of the vertex would be negative b over 2a, comma f of negative b over 2a. So let's go ahead and plug that in. So I have x squared plus 3x minus 10. A is 1, b is 3, and c is negative 10. So I have the vertex here is negative b, that is negative 3 over 2 times a, and f of negative 3 over 2. So I have the x coordinate. Now how do I get the y? I have to find the function value. So f of negative 3 over 2 would be negative 3 over 2 squared plus 3 times negative 3 over 2 minus 10. And that would give me negative 12.25. So my vertex here, negative 3 over 2, is negative 1.5 and negative 12.25. And the next step is to find the x-intercepts. How do I find x-intercept? I set y equal to 0. So 0 is equal to x squared plus 3x minus 10. So I'm going to go ahead and see if I can factor these. So I'm trying to find the factors of negative 10, which add up to 3. X plus 5 times x minus 2 equal to 0. So I get x plus 5 equal to 0 and x minus 2 equal to 0. Excuse me. So x is equal to negative 5 and x is equal to positive 2. My y-intercept, I plug x as 0. So I have 0 squared plus 3 times 0 minus 10. That would be a negative 10. So using these points, if I go ahead and graph my quadratic function, I'm just going to squeeze it in here. It would be negative 5 and 2. My vertex is negative 1.5, so I'm going to say somewhere here. And my x-intercept is negative 10, so somewhere here. So this is negative 5, 2, negative 10, and this is the vertex, negative 1.5 and negative 12.25. The leading term here is negative 4x squared. So the a value is negative 4. That means that's going to be an inverted parabola, something like this. So this function would have a maximum value. Find the maximum or the minimum value. Determine where it occurs. Remember, the vertex gives me the maximum or the minimum value and also where it occurs. So if I have a function f of x is equal to ax squared plus bx plus c, the vertex is negative b over 2a, and f of negative b over 2a. This f of negative b over 2a is the max or the min. And this negative b over 2a is where it occurs. Okay, so let's go ahead and look at the negative b over 2a here. So that would be negative 8 over negative 4 times a. And negative 8 over negative 4 is 2. So I have to have negative 8, f of negative 8 over negative 4. So that's going to be 2a, I'm sorry, this is going to be a 2 times 2 times 2. So negative 8 over negative 4 times 2 is 1. And I'm trying to find the function value of f of 1. Do the here because I don't have enough space here. So now I have 1 comma f of 1. So let me go ahead and find what f of 1 is. F of 1 would be negative 4 times 1 squared plus 8 times 1 minus 3. So f of 1 would be 1. And at what point is it? At 1. So here the maximum value is 1 at 1. Now domain. Finding the domain of this function. This is a quadratic, so the domain is all real numbers. And the range, remember we just found out the maximum value of this. The maximum value is 1, which is included, and the minimum value would be negative infinity. And that is the range of this function. Problem 4. Among all pairs of numbers whose sum is 16, find a pair whose product is as large as possible. What is the maximum product? Let the two numbers be represented by x and y. And let p be the product of x and y. And what information do we have? They say that the sum of the numbers is equal to 16. What does that mean? That means one of the number is 16 minus x. Now that we have one number, we're going to go back and plug it in here. So instead of x times y, we're going to replace y with 16 minus x. And that is equal to 16x minus x squared. So looking at the negative sign, we know that it's going to have a maximum value. And how do I find the maximum value? The maximum value would be simply f of negative b over 2a. And that is f of negative 16 over 2 times negative 1, because the a value is negative 1 here. And that is equal to f of 8. And x is equal to 8. Y is equal to 8. Because I know that the maximum value is at 8. So if one number is 8, by default the other number is 8. And 8 times 8 would give me a 64. Or I can go ahead and find the function value at 8, which would still give me a 64, sorry. Did I say 54? 64. So 16 times 8 minus 8 squared is equal to 64. So two ways of finding it. So here, the maximum value is going to be at f of 8. So the vertex, or you can also take it as a vertex, that is 8 comma f of 8, which is 8 comma 64. So the maximum value is 64. The maximum is 64 at 8. So if one number is 8, automatically the other number is also 8. So now I am going